All right, we're back. We're on page 9 of Calc AB Notes 24, differential equations. We're halfway through the problem, so we actually have already done A, B, and C. And what we want to do now is part D. So I'm going to need this differential equation, so I'm going to just copy it down first. And you should probably also do that because you're also going to need it. So I'm going to say dy, you're not a pen, dy dx is 2/3 x plus 2y minus 2. 2y minus 2. Okay, now what are we trying to do? We want to find the values of m and b for which y equals mx plus b is a solution to the differential equation. We have already done this. We actually already know the answer, but maybe we don't realize it. I'm going to show you two different ways to do it. So the first one is like a more general process that's going to work in more scenarios. So what we do is we have dy dx written one way. It's 2/3 x plus 2y minus 2. If y equals mx plus b is a solution to the differential equation, we definitely know another way to write dy dx, right? So if just based on this, I can take the derivative and say that dy dx must be m, right? There's no alternative, right? So that's from taking the derivative. Okay, so that's one way of writing dy dx. The other way of writing dy dx, if you look over here, we have dy dx is 2/3 x plus 2y minus 2. There's a y in there, right? You see that y? Well, we know another way to write y. Y is actually mx plus b. So we can rewrite this. So I can say dy dx is 2/3 x plus 2 times the quantity mx plus b, which is what y is equal to, and then subtract 2. I'm going to clean this up a little. So dy dx is, what is the coefficient of x? There's 2/3 x and there's 2mx. So the coefficient of x overall is actually 2/3 plus 2m, and then that's times x. Now, how about the constant? There's a 2b and a minus 2. So I'm going to say plus 2b minus 2. All right, so how does this help? Well, and so this is by substitution, I guess I should say. By substitution. There's no way you can read that says substitution. I mean, maybe you can. I think you're just being generous. By substitution. So we've written dy dx two different ways. If we write it two different ways, they should be equal to each other because it's like two versions of the same thing. So look at them, and you can see that on this one, we have a coefficient of x. Now look at the other version. Is there even an x in it? There's not. You can make it a little less confusing by saying, if there's no x, there must be 0 x's. And so the coefficient of x here is just 0. There's also a constant. So the constant here is this. The constant here is this. So that color is really close to that other color. Let me just, I don't really like to use this color, but it's fine. It's fine. So we have constants, and the constants must be, if two things are equal, then like the coefficient of x on one is the coefficient of x on the other. Coefficient of z on one is the coefficient of z on the other. The constant for one is the constant of the other. So if that's true, then we can actually get two equations out of this. The first one is from the coefficients, right? And the coefficients, we used this color. Based on the coefficients, I know that 2/3 plus 2m should equal 0, which means that m should be negative 2/3 divided by 2, negative 1/3. So m should be negative 1/3, just based on the coefficient of x in each of these forms of the same thing. Now, there's also the constants. Let's color code that a little bit. So for the constants, we get 2b minus 2 equals m, right? So that's just taking the constant from one form is equal to the constant from the other form. Why do they have to be equal? Because they're the same thing. right? If they represent the same thing, they got to be equal. Now, we already know that m is negative 1/3 because we just found that. So we can do this. So I'm going to add 2 and get 6/3. So 5/3 divided by 2 is 5/6. B is 5/6. So I think that my answer to this question is m is negative 1/3 and b is 5/6. Do you feel like that's a familiar answer? Because I feel like it is. If we go back and look right here, when we found the line that divided the different types of concave solutions, concave up, concave down, look at what we got. We got this. We actually got that line. This sort of suggests another way to do this problem. The other way to do this problem is to say, if y equals mx plus b, then the second derivative should be equal to 0. Now, we already found the second derivative, so I'm just going to go up and get it so that I don't have to do that. Oh, crashed it. Going back. Okay, so I don't have to do it again. So it's 4/3 x plus 4y minus 10/3. So I'm not going to remember that. 4/3 x plus 4y, I think, minus 10/3. 4/3 x, 4y minus 10/3 plus 4y minus. Okay, yeah. So that's from taking the second derivative. If you don't remember how to do that, go watch the previous video. It's all in there. So I've written the second derivative 2 different ways. This only works for a linear solution, by the way, and it only really works because we know the concavity would have to be 0. The second derivative has to be 0. But it always works, and you are frequently asked this question. So like, what the heck? Why not know it? So we need this to equal 0, which means y is equal to negative 1/3 x plus 5/6. So this is another way to get the answer. Is it faster? I don't know. It's also like less generally applicable. So I don't know that it's super important to know it, but man, knowing that that line divides that particular slope field is really useful. So this, I solve for y to get this. So I think that's a useful thing to know. Let's try this one. So it's like basically the same problem. So I'm going to start, it's like actually almost exactly the same problem. So I'm going to start with the differential equation again. So dy dx, I'm just copying it from above. 2/3 x plus 2y minus 2. And I'm going to do this in essentially the same way, right? So if I take the derivative, dy dx, it's going to be a times re to the rx plus m. So that's by taking the derivative. So take derivative. And I get that. Now what I'm going to do is I'm going to go over here and I'm going to notice there's a y. And I'm going to look here and see that there's a y. I can substitute, right? So I can also write dy dx equals 2/3 x plus 2 times, well, what is y? Y is ae to the rx plus mx plus b. Kind of gross. And then minus 2, because we're just substituting, right? So this is y that we substituted. Okay, we should definitely clean this up. So we get dy dx is, so I'm going to write 2a e to the rx. The coefficients of x are 2/3 plus 2m, and that's times x. And then the constant is plus 2b minus 2. Okay, now we're doing the same thing. We wrote the derivative 2 different ways, so they should be equal to each other. So I'm going to start hunting for things that are equal. Well, I've got a coefficient of e to the rx and a coefficient of e to the rx. Okay. And then I have a coefficient of x here, and I look at my my other form and I don't see an x, so what I do to pretty it up is I put in a 0 times x. And then I just say, all right, well then that's 0. Okay, so far so good. And then I need the constant will give me another equation. And we're good to go. I have 3 equations and 3 unknowns. I don't know what A is, I don't know what M is, I don't know what B is. Those are all the things that I'm being asked. Oh wait, no, I don't know what R is. What don't I know? I don't know what R is, what M is, or what B is. And those are the things that I'm being asked. And then the question says, what's the story with A? So I think I kind of know the story with A. So let's do coefficient of e to the rx. So what color are you? That's going to be this nice blue color. I like this color. It's a pretty color. I like it. So that gives me 2a equals a times r. So from that, I know that, like either a is equal to 0 or r equals 2. So that's interesting. So r equals 2. And it looks like it doesn't matter what a is. Like it looks like a could be any number, and that would still be true as long as r is equal to 2. So that's really interesting. I think that's the story with that. So we get coefficient of x, which is this gross color. No, it isn't. It's another nice color. I like this color as well. You know what I don't like is the one that I use for the constants. Not that I don't like, yeah, I don't like it. It would be disingenuous to claim that I like it, because I definitely do not. This should equal 0, which means m is negative 1/3. Well, this is suspicious. M is negative 1/3 again. M was negative 1/3 up here. Is B going to be 5/6 again? So the constants give us our last equation. So the constants use this ugly color. I shouldn't be so mean about the colors, but you know, it's ugly. 2b minus 2 is equal to m. So 2b minus 2 is negative 1/3. So b is, we get 5/3 divided by 2, we get 5/6. We got the same values for m and b as we got before. But that kind of makes sense if you think about what the slope field looks like, which hopefully, if you go back and watch, you can look at the slope field. There's the line, right? Y equals negative 1/3 x plus 5/6. It's kind of like cutting the whole thing in half. You know what? I'm going to do it. I hope this doesn't mess up the entire video. Hopefully we can come back from this. Actually, I can't even find the calculator, and I feel like that's going to be a problem. Let me see here. Share the calculator. Okay. So this is already set up. This is the slope field. And let me get rid of this line. Delete you. So you can see there's like solutions. For all of the solutions, this line is actually a slant asymptote, or it is the solution. And so it makes sense to me that y equals negative 1/3 x plus 5/6 would show up in every type of solution. And then there's just, there's a question of, is that exponential there? So if a was equal to 0, there's no exponential and we just get the line. If a is positive, we're above. If a is negative, we're below. I think all of that is true. But anyway, the slope field really informs your thinking on this. So let's go back to the notes for like 1 second, hopefully, and take one last look at this. This is a big deal concept, right? So not super challenging. You just have to get acquainted with the idea of equating coefficients is really the process. So let me like write that down. I'll write it down in like blue. Okay, I'll write it down in blue pen. We solve these by equating coefficients. And it's really similar. You did this with complex numbers. If a plus bi equals c plus di, then a equals c and b equals d. Same idea. you're just applying it to differential equations here. Anyway, this is what we're doing. So I hope you understood this. You might need to watch it again, maybe try a couple, but I hope you found this helpful. I will see you in the next video.